Okay, here we go. Page 6, section 8.1. This is a long section. We wouldn't have been able to cover this in just one day, I think, if we were meeting face-to-face. So that's kind of one of the nice things, I guess, about the situation we find ourselves in, right? Anyway, so let's finish up 8.1, page 6. So example 6 says, the mean speed limit in Montana is 54 miles per hour with a standard deviation of 12 miles per hour. Describe the sampling distribution of the sample mean for a sample of 40 roads in Montana. Okay. So in the past, right, we've looked at several problems like this in this section. And we've always been running simulations to try to answer these questions. But we don't have to run simulations anymore because we have these formulas that we've worked out, right? Like, we can describe the center, we can describe the spread, and we can describe the shape thanks to the central limit theorem without having to run the simulations. So when you get to the homework, this is how I want you to do these kinds of problems, okay? When they ask you to describe the sampling distribution of the sample mean, this is how I want you to do it. I don't want you to run a simulation. I want you to do it how I'm going to show you right now. Okay? So to do this, we would say, well, we know that we're talking about a sample mean of 40 roads, right? So our sample size is 40. And so we can say so let me write out. This is to describe the shape. Okay, so as far as the shape is concerned, we can say since n equals 40, which is bigger than or equal to 30, right? Remember, 30 was our cutoff point. As long as n is bigger than 30, we can say that x bar is normally distributed. And since 40 is bigger than 30, x bar is normally distributed. Right? So x bar is bell-shaped, right? That's the shape of the distribution. The center of the distribution, mu sub x bar. Well, what we've discovered in this section is that mu sub x bar is the same thing as mu. It's the same thing as the population mean. And the problem tells us the mean speed limit in Montana is 54 miles per hour, so we would say mu equals 54. Okay, and that's the center. And then the spread, sigma sub x bar. Well, we've discovered that sigma sub x bar is the same thing as sigma divided by the square root of n. In this case, we're told the standard deviation is 12. And the sample size we said was 40. So the spread is 12 divided by square root of 40. Let's see about how much that is. 12 divided by square root 40. That comes out to about we'll say about 1.9. Okay, and that's that. Okay, so again, when you're going through the homework and they ask you, describe the sampling distribution of the sample mean. What they're asking you to do is to describe the shape, center, and spread of the distribution. So you need to tell them the shape is normally distributed if this condition is met, right? You need to tell them the center, right, which is the same as the population mean. And you need to tell them the spread, which is the population standard deviation divided by the square root of your sample size, okay? And that's that, okay? So that, in a nutshell, is a summary of what we've discovered in this section. Okay, that is basically what it boils down to. Here's why we want to know that information, right? So this next example is a summary of why we want to know this information. We want to know this information so that we know how to compute probabilities involving x bar. So here's the gist of the idea. If we want to compute a probability involving a single observation of a normal variable, then we use the normal calculator with the values for mu and sigma given in the problem, just like we did in 7.2, way back in 7.2. But if we want to compute a probability involving a sample mean of multiple observations, we can still use the normal calculator, but we have to use sigma divided by the square root of n for the standard deviation. Okay, that is the main difference right there. Okay, so let me give you an example of this. Okay, so number 7 says, the heights of women are normally distributed with mu equals 63.6 inches and sigma equals 2.3 inches. If a woman is selected at random, what is the probability that her height is more than 64 inches? Okay. We've been through problems like this before. So what I want you to do is pause the video and work out this problem on your own. Okay? I'm going to give you the solution now in 3, 2, 1. Okay? So, if a woman is selected at random, we're not talking about a sample of a bunch of women, we're only talking about a single woman, right? So if one woman is selected at random. So what that means is we're going to be doing the stuff that we did in 7.2, right? We're going to be doing like the first scenario up here, okay? So we know that the heights are normally distributed. That means we can use the normal calculator. So we're going to go to Stat, Calculators, Normal. When we get there, we're going to be prompted to enter something for the mean. Well, we're told that the mean is 63.6 inches. And we're going to be prompted to enter something for the standard deviation. We're told the standard deviation is 2.3 inches. Okay, and that's the value that we're going to use for the standard deviation because we're only talking about just a single woman, right? A single woman. Okay, so we're looking for the probability that that woman is more than 64 inches tall. So we're looking for the probability x is greater than 64. So let's go to StatCrunch, figure out this probability. Okay, so we'll go to Stat, Calculators, Normal. We'll put in 63.6 for the mean and 2.3 for the standard deviation. Now we're looking for the probability that this woman is more than 64 inches tall. And rounding that to 4 decimal places, we'd say that's about 0.4310. Okay, 0.4310. Okay. So that's that one. Now, I want you to compare and contrast that with part B, which says, if 10 women are randomly selected, what is the probability that their mean height is more than 64 inches? Okay. So I'll give you a second to pause the video, try this one out, see if you can get that probability and see the difference between parts A and B. I'm going to give you the solution now. So So the difference between part B and part A is that in part A, we were only looking at if a single woman was selected, what was the probability she was more than 64 inches tall. In part B, we're looking at if a sample of 10 women are selected, what's the probability that their sample mean is more than 64 inches. The good news is that since the population is normally distributed, we know that X bar is also going to be normally distributed. And so we can use the normal distribution, the normal calculator in StatCrunch to compute this probability. So again, just like in part A, we're going to go to Stat, Calculators, Normal. But this time, when we're prompted to enter something for the mean, we're going to put in mu sub x bar. Okay? Mu sub x bar happens to be the same thing as mu. Right? That's 63.6. For the standard deviation, we're going to put in sigma sub x bar. Sigma sub x bar is sigma divided by the square root of n. Okay, so that's 2.3 divided by the square root of our sample size. We have a sample of 10 women in this case, so we're going to divide by the square root of 10. Okay, let's see what we get. 2.3 divided by square root of 10. That comes out to about 0.73. Okay, so then we're going to go to StatCrunch and compute this probability. Now, we're looking for the probability that their sample mean, x bar, is greater than 64. Okay, let's take a look. Okay, so I'm going to Stat, Calculators, Normal, right? This was part A. Maybe I'll switch them around so it's not as confusing. Right, this was part A, and now here's part B. Okay, we want to put in a mean of 63.6. We want to put in a standard deviation of 0.73. And now we're looking for the probability x bar is greater than 64. Okay, and that's that probability, about 0.2919. I'm not going to switch back to the notes just yet. 0.2919. Okay, because I want to talk about this. Okay, so notice that this probability is much smaller than this one. Okay, it's almost half, right? It's almost half of this one. Well, it's a little more than half, right, of this probability here. That should make sense, right? Because 64 is more than average. Okay, 64 is a little bit more than average. So if you're just talking about, randomly selecting one woman and asking what's the probability that she's taller than average, well, there's going to be a pretty good chance that she's taller than average, right? But if you're talking about a random sample of 10 women, okay, if you're talking about a random sample of 10 women, and you're saying what's the probability that their sample mean is larger than average, that's not going to be quite as probable, right? The probability is going to be, that's going to be less likely. It's going to be less likely that their sample mean is larger than average, okay? Because you might have a couple of women in your sample who are taller than average, but you're also going to have a couple women in your sample who are shorter than average. And so the probability that their sample mean is larger than average is going to be smaller than it would be for just a single woman if you were just asking about a single woman. Okay. So hopefully this makes some intuitive sense to you, right? Now that I've explained that, right? That this probability would be smaller than this one. But the moral of the story is that these two problems, parts A and B, are almost exactly the same. The difference is that in this one we're looking at one woman, in this one we're looking at a sample mean of 10 women, and the thing that affects is the standard deviation. Okay, here we had to divide by the square root of 10. Okay, that does it for 8.1. It's kind of a doozy of a section. Again, this is a section where students definitely struggle a little bit, but do the homework. if you need to, rewatch the lectures so maybe you try out the problems and maybe you're a little fuzzy by the time you finish the homework. It might be a good idea to come back and rewatch the lectures then. That's one of the luxuries of kind of moving the course online. You can rewatch the lectures, and maybe it'll make more sense to you now that you've worked through the homework problems once, right? If you have any questions, please comment in the module, in the discussion board there in this module of material, and I'll try to get back to you and try to answer your questions, okay? But that's that. So there's the homework assignment, and I will post this today.